All right, we're doing the AP Calc, AB 29 FRQ, 2019. Question 3A. So basically, this is saying from -6 all the way to 5. The area under the graph on that interval is 7. But we know that this is just of f of x. We can break this up into -6 to -2, which is what we're looking for right here. Plus -2 all the way to 5. Right? Because this is -2. So this portion of the graph plus this portion of the graph equals the whole graph. That's what this is saying. So if we rearrange this, we can see that the thing we're finding, the integral from -6 to 2 equals from -6 to 5 minus -2 to 5. And we know this is 7 already, that's given. So we just need to find this is what we're looking for. So how do we find this? Well, area is just, or no, the integral is just the area, right? So we can just find the area of this section. So we'll break it up into 3 different, here, let me zoom in. Break it up into 3 different sections. There's this triangle, and this sort of thing. Now this triangle is easy, it's just 1 by 1, so that's, that is 1 times 1 times 1/2. This triangle is 1 tall, we can see it's 1 tall, but we don't know how wide it is. Well, it's not obvious how wide it is, but we can actually see that since this point is at -1, no, this point is at 0, -1. I'll do this in black. And this point is at 2, 3, which means the slope of this line is 4. No, the slope of this line is 2, 4 over 2, or 2. And since the problem said that these are 2 line segments, we know that if the slope of the line is 2, then this must be the point 1/2, 0. Which means that the width of this portion is 1.5, or 3/2. So we have those. Now for this final section, I'll do it in blue. We are told that it's also made of a quarter circle. So this is the quarter of a circle centered at this point. So that makes this pretty easy because it's just a parallelogram. Or no, it's just a trapezoid minus this part minus the quarter circle. So knowing that, we can zoom back out and see that, here, I'll wait. I'm gonna make this fancy. Change the color to yellow. So this equals, well, it's the yellow triangle, which is 1/2, 1 times 1, plus, plus the red triangle, which is 1/2, 3/2 times 1, plus the blue area, which is plus, let's see, so trapezoid 1/2 base 1 times base 2. So 1/2, 4.5, so 9/2 plus the top part is 3 times the height, which is also 3. And then you subtract the purple minus, it's a quarter circle, remember that, so it's 1/4. And then we see the radius of the circle is 3, so pi 3 squared, pi r squared. So this is this integral, which means we just simplify, we get 1/2 plus 3/4. Actually, I'm going to make this 2/4. 2/4 plus 3/4 plus, let's see, 9/2 plus 3 is 15/2 times 3, 45/2 over 2, 45/4, and then minus 9 pi over 4, which goes to 50, oh wait, hold up. I also forgot one other thing. This is negative because it's below. Shoot, that's fine. See how it's below the x-axis? That means it's negative. So this should actually be a minus, and this should be a minus. So that equals 44 minus 9 pi over 4, or 11 minus 9/4 pi. So we're actually trying to find the value of this though, right? Since we know this and we know this, we can just put those together. 7 minus what we got for the answer equals 9/4 pi plus 4. Wait, minus 4. So that is our, whoops. That is the answer for part A. Now part B, evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 d of x. So the first thing I notice here is that you have an integral and you have a derivative. See, right here. And since those are just the opposite of each other by the fundamental theorem of calculus, here I'm going to move this down. Since those are the opposite of each other by the fundamental theorem of calculus, they can cancel out. So we are left with 2 f of x plus 4x, and then the limits of integration. And all we got to do is solve this normally. So plug in the 5, plug in the 3, and then simplify f of 5. We can look at the graph is 0, and f of 3, f of 3 is given. It's the point 3 minus rad 5 is in the graph. So f of 3 is 3 minus rad 5. So that's 0. So 20 minus 2 times 3 minus rad 5 plus 12, which is 32 minus 6 plus 2 rad 5 Or, oh wait, hold up, I did something wrong. This should be subtracted like this. There we go. Yeah, okay. So now we're subtracting 12, so that's 8 there. And then that gives us 2 plus 2, we're at 5. So that one's pretty easy, just a fundamental theorem of calculus question. C, a function g is given by that, find the absolute max on the interval -2 to 5. All right, so absolute max. What does absolute maximum mean? Hold up, oh, whoops. Move this over here. Absolute max means we are going to find the derivative. So, right, because the derivative, when there's an absolute max or an absolute min, hold on. The derivative when there's an absolute max or maximum absolute min is 0, right? So we find the derivative here and set it equal to 0 to find that all the possible absolute maxes. And we also look for undefined areas because that is another critical point. But looking at this graph, we don't have any undefined areas. We just have -1, 1/2, and 5. And since it's an absolute maximum, we also look at the endpoints, so -2 as well. So those are values we're considering. What was it? -1, or I guess -2, -1, 1/2, and 5. And then we also have to find the derivative of g, so it's just the derivative of this, which again, fundamental theorem of calculus, d over dx of, remember we can just bring the x down here and then these cancel out the integral with the derivative. So we get g prime x equals f of x. And actually I jumped the gun here because I've already solved the problem to make sure I knew how to do it. But yeah, so f of x equals 0. So now we just look at where is f of x 0? Well, it's here, here, and here. And we also have to look at the endpoints since it's an absolute maximum. So also there. So x equals -2, -1, 1/2, or 5. Now we just test all these values. I'll do those over here. G of -2, G of -1, G of 1/2, and G of 5. So G of -2, well, that's just the integral from -2 to -2 of f of t, which, since it's from -2 to -2, that's 0. And then from -2 to -1, well, we can see, it's this area up here. So that's 1/2. Now G of 1/2 is this first triangle minus the red triangle, because the red triangle is negative, remember that? Which gets us 1/2 minus 3/2 or no, 1/2 minus 3/4 equals -1/4. And then g of 5 is this, right? -2 to 5, which we calculated in part A to be 9 pi minus 4. Wait, no, 11 minus 9 pi over 4. So obviously that one's the biggest. And just visually, you can tell that this, the blue is far greater than the yellow or the red. So this is definitely the biggest. The maximum is at x equals 5. And then I guess we have to justify. So basically just what I explained is that the justification is we can take the derivative, set that equal to 0, test all the values, find the highest one, and that happens to be at 5. So now D, find, here I'm just, whoops. Just do this. So find this limit, which is, just plug in, yeah, it looks like you just plug in x equals 1, so that's nice. 10 to the first minus 3 f prime of 1 over f of 1 minus arc tan of 1. And that is just simplifying 10 minus 3 times, let's see, f prime of 1 is, all right, so this goes back to, again, remember how we said the slope of this line segment, oh wait, I got a highlighter, oh. Slope of this line segment is 2, which means the derivative there should be 2. So we can say that's 2 over f of 1 is 1 minus arctangent of 1 is pi over 4. So 6 over 1 minus pi over, wait, nope, 4 over 1 minus pi over 4 is our answer for part D. All right, so number 4. This, you can read through it. It's a related rates problem. So part A, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. This first one is pretty straightforward, just a normal related rates problem. So we just see that it gives us the formula. So we take the derivative with respect to time. And when we do that, we get dv over dt equals pi r squared. Oh wait, we also know the radius. Our radius is 1 foot. So pi 1 squared times dh over dt. And that means when the height of the water is 4 feet. Oh, so dh dt right here, it gives us what it equals. So we can change this into pi times that, and then height of the water is at 4 feet. So that's 4. And we get, that's 2, so -2/10 is -1/5 times pi. or I'll just do it here to save space, negative pi over 5. So it's just related rates. Just take the derivative of the relationship, which is this, and then each problem will be a little bit different, but yeah. In this one, all we had to do was realize that it gave us dH over dt. So part B is a little bit trickier. It's kind of worded weird. When the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing? So this is asking if the rate of change of the height of the water, the highlighter, not the height of the water itself. It's asking about the rate of change, which is kind of like acceleration, right? The rate of change of a rate of change, which is a second derivative. So we just need to find the second derivative of height with respect to time, which means we just take the derivative of this formula again. And that equals, so power rule, this is just h to the 1/2. So bring down the 1/2, we get negative 1 over 20 times root h times dH over dt. So dH over dt is just defined previously here. So we can plug that in. We can plug in dH dt times, and then these cancel and the negatives cancel. We're left with 1 over 200 feet per second squared. Oh, also this mentions indicate units of measure. So it's in feet cubed per second, because it says it gives us feet and seconds. So this is just asking for increasing or decreasing. Since this is greater than 0, we can say it's increasing. And then to explain our reasoning, just say we take the second derivative because that is the rate of change of the rate of change. Saw that was positive, which means that it is increasing. So now, part C, at time t equals 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So h in terms of t, we got to use separation of variables, which just means this dH and dt here, I'll write it here. We just want to separate these. Separate the dH, the h from the t. So we could treat this like a fraction and say that dH over rad h. Oh, we also want to bring all the like variables to one side, just like normal algebra, times dt over 10. Now, to get rid of the d part, the slight change in the height and the slight change in the time, we can just integrate these. And this is just basically the integral of 1 over rad h dh, which is, let's see, h to the negative 1/2 plus 1 is 1/2. Invert that, 2 times So that equals just t, negative t over 10. Oh, and I forgot, these are indefinite integrals, so we have to add constants, plus c plus d. So these are different, or not necessarily the same, so I use different letters. But the cool thing with the unknown constants is that we can just say some other unknown constant, e, we'll say e equals d minus c. So 2 rad h equals negative t over 10 plus e. And there we go, we got rid of one of the random ones, one of the random constants. So now the question says at time t equals 0, the height of the water is 5 feet. So just plug those in. Equals 0 plus e. So e equals 2 rad 5, which means we can rewrite this. 2 rad h equals negative t over 10 plus 2 rad 5. Oops. So now we're finding h in terms of t. So we want to get this h all alone. This is just normal algebra. So divide both sides by 2. And then square both sides. And that is our final answer. Okay, now let's do 6. This one's kind of tricky, actually. I mean, I guess you could say all of them are tricky, but this one I'd say is the most tricky. So functions f, g, and h are twice differentiable. With this, the line of that is tangent to both at x equals 2. So find h prime of 2. So this is the derivative, which measures instantaneous rate of change. And it says this line is tangent at x equals 2, which is just h of 2. So if you'd imagine, let's see, it's 2/3. So something like this. And the graph of h goes like this. Oh, whoops, that's not good. And this is it. This is x equals 2. Right? Just imagine. That means that the tangent line is the slope, right? So this is just 2/3. Or the slope of the tangent line is the derivative, is what I'm trying to say. So now part B, let a be the function given by that, write an expression for a prime of x and find a prime of 2. So a prime of x is just take the derivative. Just normal product rule stuff. So 9x squared times h of x plus 3x cubed times h prime of x. That's a prime of x. That is as the first part of the problem. Now find a prime of 2. Well, when we plug in 2, we see that we need h of 2, and we need h prime of 2. So h prime of 2, we found in part A, h of 2 is given right here, and it's 4. So we can just simplify this out. 9 times 2 squared is 36 times 4 plus 24 times 2/3. which is 160. So those are our two answers for part B. Just to are more straightforward, I'd say C and D are a bit more tricky. So C, the function h satisfies that, where x does not equal 2. This part's important. The limit can be evaluated using L'Hopital's rule. So use the limit to find f of 2 and f prime of 2 and show your work. It says that limit can be evaluated using L'Hopital's rule, which means that this, the limit, must equal an indeterminate form. And since we can see that the top of the limit, if you plug it into right now, would be 0, we also know that the bottom is 0, which means that 1 minus f of 2 cubed equals 0, which means that f of 2 equals 1. So that's f of 2. Now for f prime of 2, well, we know that h of 2 is 4, and since I'll write this out. H is differentiable. Therefore, h is continuous. Therefore, h of 2 equals the limit as x approaches 2 of h of x. Right? These are all just, like, by definition, they work. Which means we can say, since we know h of 2 is 4, that's given in the problem, we can say 4 equals the limit. So let's see if this works. Oh, wait. Boom. Fancy. So now this equals 4, which means that, oh yeah, we have to do L'Hopital's rule. So we'll take the derivative of the top and bottom, 2x over, don't forget the limit, 2x over, so we do power rule, and then chain rule, equals 4. Now we can plug in 2. We get 4 over f of x, or f of 2, we just saw is 1. So 1 squared times 3 is 3, times f prime of 1 equals 4. Simplify this, and we see that f equals 1/3 f prime of 2. This should say 2. F prime of 2 equals 1/3. Oh, this is a negative 3. So negative 1/3. Let me just, for part D, the big boy. This one you have to justify your answer, so there's a bit of writing involved. It is known that g of x is less than h of x, which just means that the output of g is always less than the output of h on this interval. Now let k be the function satisfying this on the same interval. Is k continuous at x equals 2? So first, okay, I guess there's a few ways you can do the order, but the way I did it, I mean, it's the same logic either way, no matter what order you do it in. I'm just gonna move this down here. So this first reminded me of the squeeze limit theorem, which states that it's the squeezy theorem, see? It's the really cool picture. Oh, we'll do galaxy because it's really cool. Neo. Oh, that's a really bad picture. But it's the one that squeezes, I guess. G of x is less than h of x on this interval. And less than or equal to. Which means, so this is like saying this is g of x, this is h of x. Which means, oh, and also, k of x lies between those two. Which means by the squeeze limit theorem, oh, that is not pretty. By the squeeze limit theorem, we know that the limit as x approaches 2 of, wait, big brain this. Oh shoot, that's not what I wanted. No. Oh yes, alright, sick. I just get tired of writing limit over and over. The limit as x approaches 2 of g of x is less than or equal to the limit as x approaches 2 of k of x is less than or equal to the limit as x approaches 2 of h of x. So we know that, and since it says that h or g and h are differentiable functions, which again means that the limit at one point equals whatever the graph equals at that point. So since are, oh my god, differentiable, they are also continuous. Meaning that the limit as x approaches 2 of g of x equals g of x, or g of 2, and that it's given that that equals 4, and also the same is true for h of x. Now going back here, we can apply this to here and see that the limit as x approaches g of x, or as x approaches 2 of g of x is 4, is less than the limit as x approaches 2 of k of x is less than limit as x approaches 2 of h of x, which we also saw was 4. Therefore, the limit as x approaches 2 of k of x equals 4. So that's one part of our continuous, of our proving it's continuous. The second part, we have to show that this equals k of 2, because we're finding it continuous at 2. This part's easy. We also know that g of x is less than or equal to k of x is less than or equal to h of x. That is given in the problem. We also know that g of 2 is 4 and h of 2 is 4. So 4 is less than k of 2 is less than 4, which means k of 2 equals 4. And we see here and here that I'm not going to have enough room. That limit as x approaches 2 of k of x equals 4, or no, equals k of 2. And that is the definition of continuity. So k of x is continuous at x equals 2. That is our justification. So hopefully that was helpful.